All right, so good evening, everyone. So once again, welcome to our monthly APOD session conducted by Astronomical Society of Penang. And yeah, I'm glad to see you all again online because I have not been joining this APOD session for quite a few months. So yeah, as usual, all right. I miss every one of you, and yeah, now this month I'm back. Okay, so yeah, a brief introduction. I'm Lai, a committee member from Astronomical Society of Penang, and tonight, with us for this APOD session, we have Dr. Chong, President of Astronomical Society of Penang. All right, he is always with us in almost every session, every APOD session, right? And then next we have the flower of ASP, Miss Chiu Boon Wei. All right. She requests me to announce that she was 18 this year. No, sorry, she's 18 this year. Okay. So yeah, we have a lot of young members tonight. Okay. And also together with us, all right, is also our old friend, Ray Yen. All right. He have been joining a pop presentation, I think, few months ago. And when I was not here, he is still here, and now he's still joining us this month. And also today we have our not new friend actually, because Marcus did join us, I think last year to present APOD. So yeah, and today, all right, this month he's back. So once again, we welcome Marcus. All right, both Rayan and Marcus are our very young members. All right, and they give a lot of talks and presentations in our ASP event. All right. So as usual, the APOD for this month, right? We will present selected APODs, and let's start with today APODs. So we'll go to the APOD on 30th of October. All right. I will share a window. Right. So let's see. This is the APOD for 30th of October. Right. Today's APOD.
Yo, yo, yo.
Image. All right. A very nice picture. Taken by Stephen Witter. Right. A French. He's actually a doctor, I guess, because I browsed through his Facebook profile just now. All right. He works in this SOS medicine. It's a sort of organization where if you have emergency issues, you don't go to the clinic, but the doctors go to your house, right? So I think he managed this website called Nuit Sacrés, all right? Nuit Sacrés, a French website on astrophotos. So he might be an amateur astrophotographer, all right? And the title of the photos today is Night on Spooky Planet. So yeah, this image is taken in Hurul, all right, a city in Iceland, all right, city in Iceland, where we see that the geomagnetic storms produce the aurora on the sky over here, right? The green aurora. Aurora is actually almost every month we'll see photos for aurora in APOD, all right, and this is a geothermally active area, all right, in Iceland. So this is actually steam, right? This is actually steam from the ground, all right, from the underground, the thermal heat. Okay. So let's see the caption, right? So this is planet Earth, of course, all right, and then the ghostly towers of steam, right? So these are the ghostly towers of steam, and gas are venting from fumaroles. All right, fumaroles are actually the vents or opening at the surface of Earth when the volcanic gases or vapors are emitted. So this is the fumaroles, and that's the area of greenish light. So the greenish light is over here, and for now, aurora apparitions are increasing in our sun approaches its maximum in its 11-year solar activity cycle. So in fact, these photos are not taken recently. It's taken back in 2013, all right, where we see the solar cycle, the solar cycle. In 2013 over here, all right, is almost the peak of the solar cycle. And we are currently in 2022, which are somewhere here, right? Remember back in past few years, I think 2019, 2020, and 2021, when we observe the sun in solar observation, we actually observe the sun like just a ping pong ball, as some students always mention. When they look through the telescope with solar filter, they see they say they see nothing. They just see something white. All right. So in fact, because we rarely see sunspot for the past few years because we are at the solar minimum, and now we are starting. All right, starting to going towards the peak. All right. So we are somewhere over here where we are approaching solar maximum. I guess will be in 2 years time, 2025 or 2026. Right. This is the predicted curve. So in 2013, it was the solar peak. So the sun is quite active, and the solar wind, all right, the solar wind by the sun actually collide with the nitrogen and oxygen atom in the atmosphere, causes the colorful glowing halo around the pole, so which is the aurora. So the altitude of aurora is approximately 97 to 100 97 to 1000 kilometers above Earth, all right, above Earth. So the common aurora we see is green, but it can appear in other color, all right, green, red, or sometimes if you're lucky enough, you would see the blue one, all right. So yeah, that's all for APODs today. So next, I'll pass over to Rayan to continue with the APOD presentation. So nice to meet you again. We'll see you again. Bye bye.
Lai, I'll take over from you. Okay.
Yes.
Yep.
Okay.
Bye bye. I.
Bye.
I'll share my screen. Bye. Lai, wait.
I've stopped presenting.
Okay, thank you.
See you live.
Yeah. Can you see my screen, everyone?
Yes, we can.
Okay. For now, so that's me. So it's on the 26th of October. Wait a minute. I stop. That's okay. So you have the Cocoon Nebula, 26th of October, by this Andy and Molly. I will give you more information later. So basically, this Andy and Molly is from Italy originally, migrated to America. He's a member of the Seattle Astronomical Society. Remember Seattle? Northwestern corner of America in Washington State, the city of Seattle. And this is in the constellation of Cygnus the Swan. All right. So basically, I make it smaller now. Can you see in all its grandeur? Okay. So basically, you have here a lot of things in place. So basically, we see in the APOD pictures, for example, this is somewhere in the galaxy. A lot of processes here are happening in interstellar space, in the space between the star, and they are also similar to some of the phenomena on the Earth. So whenever you see something, astrophotograph, for example, this is astrophotograph, you see, is what you see here can occur on the Earth. So some of the phenomena on this picture can occur on the Earth, but some of them cannot occur on the Earth. So basically, this is a place where some of the stars in the Milky Way, they die by blowing off the dust of gas, the clouds of gas and dust, and which will later collapse to form new clouds, the clouds. So for example, here you have the cocoon. So cocoon, we know, is like, for example, the butterfly. Before it was born, that it was born as laid out as an egg, it didn't become the cocoon. And for the cocoon, you have the pupa will come up, and later on, the butterfly will come out. So this cocoon is the one that encloses the pupa. All right. So this is not the real cocoon, but look like cocoon. In fact, looks like comet. So this is the comet head, and this is the tail. So here the comet head is about, so-called comet head is about 10 light years, and the whole object here, including the so-called tail, is about 100 light years. So basically here, you have a very bright star in the center, gives off the light, and the light is scattered or reflected off from this nebula. Okay, so either by emission or by reflection. And here you have this absorption nebula, right? The absorption nebula are the dust particles made up of silicates and so on, and the dust particles will block off the light from behind, the emission nebula behind, right? So this is a beautiful Cocoon Nebula, white field, and it is in the constellation of Cygnus. And here, this bright object is our IC 5146, in the catalog 5146. So basically, when you look into this this part of the Milky Way is actually a stellar nursery where new stars and maybe new exoplanet and hopefully new ET civilization will be born in future. Okay, we go to my next picture, which is on the 20th of October. A bit small, never mind. The famous pillars of creation. All right, but this is a bit different. This is taken by JWST. Okay, here you see here ESA, NASA, ESA, European Space Agency, CSA, Canadian Space Agency, SCSCI, the famous Space Telescope Science Institute, Institute of Hubble, and also the Institute for James Webb now, and the NIRCam. NIRCam is the near-infrared camera of James Webb, and the processing is by these people, Joseph de Pasquale of SCI, Space Telescope Science Institute, and Anton N. Komema for SCSCI, and Alicia Pagan. These are the scientists there. And basically, this is what you know. James Webb is in infrared. Now, to compare with the famous, at one time you say, the most famous picture taken by Hubble years ago. All right, this is our pillars of creation by Hubble in visible light. But this is the pillars of creation in near infrared by James Webb Telescope. Remember, James Webb Space Telescope, the only recently commissioned and is working perfectly well. So this is looking at infrared. And when you look at infrared, look at the difference of infrared, James Webb, visible, Hubble. So Hubble being invisible light, the visible light wavelength being shorter, cannot penetrate through the dust cloud. Whereas James Webb is in infrared, near infrared, longer wavelength. So the wavelength of the infrared is bigger than the size of the dust particle can penetrate through. Look a bit transparent. So beautiful, all right? And of course, we know that this is in the constellation of Serpens Cauda. Remember, this Serpens constellation, the constellation of the serpent or the snake, is the only constellation that divided into two constellations. No? You have the famous Serpens Caput, nice sounding name, Serpens Caput, the head of the serpent, and the Serpens Cauda, the tail of the serpent. This is Serpens Cauda, all right? Our M16 pillars of creation. All right? So I remember many years ago, the American newspaper called it the pillars of creation, the fingers of God. All right? So it's a very nice name for this place. Okay. You go to the next picture, 17th of October. Very weird picture. Hey, what's this? The little donut, is it? From somewhere from Queens Bay Mall or from here? No. This here, X-ray rings around a gamma ray burst. I enlarge the picture to read it first.
Actually, I thought this was the human body cell or something.
Could be. But this is the biggest cell in the universe, all right? Many light years, all right? So this is the case of a gamma ray burst. The one in the center. Now, gamma ray bursts are actually cosmological objects, meaning what? Billions of light years from the Earth. Thousands or millions of light years from the Earth. Very far away, right across the universe, and still can be detected at Earth, right? Very powerful source of electromagnetic radiation in the form of gamma ray and X-ray. By our NASA and sweep observatory, one of the NASA observatories still in space, observed in gamma ray sweep observatory. And of course, the data is obtained by B. Senko, NASA Goddard Space Flight Center, A. Beardmore, University of Leicester in UK. So, I'm sure you know, Malaysians don't know this. University of Leicester. No.
Yes, that is true.
University of Leicester. That's how you process. And the processing is by J. Miller from University of Michigan. So basically, this is about the most powerful GRD, gamma ray burst detected on the Earth, right? So they say that, for example, you have a part of the Milky Way where you have gamma ray burst occur, very intense, so intense that nearly 2 billion light years away on the Earth you can still detect. And what happened is this: why Bunway got the ring is that it gives up gamma ray. Yeah. It gives you gamma ray, the burst. At the same time, it also gives a bit of it in X-ray, and the X-ray goes horizontally and gets scattered off by the dust here. And when you reach the Earth, it looks like the ring. So that's why you see in the center you have the bright spot, and then you have the ring, which is the bright spot is caused by the gamma rays, and the rings are caused by the scattered X-ray, right? and it's very, very powerful X-ray burst. Right? So when you talk about gamma ray burst, you're talking about something very fundamental of the universe, very powerful. You know, Ryan, Marcus, Bube, how powerful is a gamma ray burst? They say that in the energy given off by a gamma ray burst is more than the energy given off by our sun many billion times over in the sun's whole lifetime. A lot of energy is given off. Okay, gamma ray burst taken by this sweep observatory in space. Right? So now I pass over to Ryan. Over to you, Ryan.
Okay. Let's try to get the screen shared. Can you see my screen?
Yes.
Okay.
Yeah.
I shall now begin with my first APOD for today. The APOD for October the 27th. Now what we have here, I'm going to move over to the screen. This is a beautiful picture from The World at Night, TWAN. Let me head back here. The World at Night, TWAN. They're an international collaboration of some 30 astrophotographers around the world who take these stunning images of world landmarks, as you can see here, paired with a truly spectacular celestial background. Now, what landmark do we have here? Well, framed in this hazy image is the magnificent Taj Mahal.
Yeah.
That's what we see here, the Taj Mahal or Crown Palace. It's found in Agra in India, and it was commissioned during the reign of the Mughal Empire. They are one of the last successors to the Mongol Empire, and they were actually the last the last rulers in terms of the empire before the British came in during the 1800s. So what happened is, well, this Taj Mahal here, it's a marble mausoleum. So it stores tombs, specifically the tombs of the Mughal Emperor Shah Jahan and his empress consort Mumtaz Mahal. Now, this building is just truly magnificent, and there are many different myths and stories that go on about. For example, I'm going to have a short MythBuster session here. Some people said that the architect's eyes were gorged out to make sure that he could not build another, and that the workers' hands were chopped off. Now, don't worry, that didn't happen. In fact, the emperor built houses and homes for the workers, much to the displeasure of his son, who later confined him. But what is meant to be the true spectacle here is an optical illusion. For those of you who are familiar or who have not been there, as you enter, it's meant to look very grand and very big. But as you get closer, it actually gets smaller and smaller the way it was built. Now, that is, of course, very different from most other things we're familiar with, especially this little thing over here. Now, what is that? You might think it's the sun, but when do we get a crescent sun? You might think that it's the moon, but then why is the moon so bright? Well, this image was taken by AJ and Nilam Talwar. AJ, he's, as I said, one of the members of the World at Night. So he's one of those around 30 photographers. And this image was taken on October 25th. So it was on the day of this year's last partial eclipse, partial solar eclipse. So what that means is let's illustrate what an eclipse is. So we have the sun, we have the earth. Now, depending on the position of the moon, you get either lunar eclipse or solar eclipse. As this was a solar eclipse, the moon is actually right in the middle. So what we see here, this is the sun. This round object here, this silhouette, is of the moon. The moon is passing in between us and the sun, creating this effect. Now, when it's on the other side, that's when you get a lunar eclipse. And there have been 2 total lunar eclipses this year. but only two partial solar eclipses. So no solar eclipses in the year of 2022. The next total lunar eclipse will be on November 7th to November 8th, so keep your eye out for that, wherever you are. Okay, that brings me to my next image. Discover the cosmos. October 18th, Milky Way auroral.
Wow.
Yeah, this one is really spectacular. Now let's have a look at it. Now I started off with the large, majestic city of Agra. Today, I bring you to, well, for this image, not today, for this image, I bring you to the small village of Obisco. Oh, no, that is Obisco, as you can see here, there. Obisco in northern Sweden. Now, Obisco is one of those villages that is definitely on the short list for one of the best places to see the northern lights or aurora borealis. As you can see here, this is a true testament to that. Now, what we have in this image, this composite image, is the northern lights, and as you can see, the great majority of it is green. Now, why is that? Well, let's understand how aurora could come about. What happens? We have the sun. Once again, we have the big sun. We have the earth. Now, the sun has large solar winds. When it passes by, or actually when it interacts with the very thin magnetosphere we have towards the pole, what happens is these very powerful and energetic solar winds collide with the Earth's atmosphere, with the particles in the Earth's atmosphere. Now, when you go above the carbon line, the majority of it is actually oxygen, which results in this green color. So around the carbon line, 100 kilometers or so, we get green. But as you go higher up to around 1,000 kilometers of altitude, you get the red color, which we see right over here. So this is much higher up. The green is much lower down. Let me change colors for that. The green is much lower down. Now, the beautiful thing about this is the way it was photographed. It makes it look as if our Milky Way galaxy, or at least the center band of the Milky Way galaxy, is blooming into this aurora. Hence, auroral flower. Now, unfortunately, that's not really what's happening. In fact, the galactic center is much larger, some 3 million billion times larger than the Earth itself, and also much further, some 10 million billion times further away from us than an aurora is. But I mean, it's a nice little optical illusion. Now, this image was taken from a lake, as you can see here, the reflection. This is a lake. This is a lake in Obisco. And the image was part of a 3-night workshop that was organized by the photographer, back here, the photographer Haran Stran. And well, the photographer, Haran Stran, is a professional photographer who has photographs and videos that can be found on National Geographic, MSNBC, Discovery Channel, and was even used by one of the UK's most commercially successful bands, Coldplay. Okay, so that is Milky Way auroral flower. Let me now head on to my last APOD, October the 1st. It may not look like much, but this one probably took the most amount of time and dedication out of all the other images. So let's talk about it. This last image that we have here, we went on talking about aurora and the galactic center. Let me now bring you back to Earth's accidental child, the one she had after smashing into a protoplanet many billion years ago. Unfortunately, this child just doesn't want to leave her side. We are talking, of course, about our moon, the moon as we know it. This image was taken over the period of some 28 consecutive nights between July 29th and August 26th. This was just shy of the actual day of the new moon. So what you really see here are the phases of the moon. We start off at new moon, we end off at new moon too. And full moon would be around this image and this image. So now, unfortunately, the images could not be taken on the new moon itself because the part of it that shines, the part of it of the moon that we can really see, is so incredibly thin that no images could possibly be taken on the new moon itself, which happened July 28th and August 27th. So just the day before and just the day after. But as I said, this took incredible dedication. Why? We need clear skies to see this. And the photographer, 45-year-old, who graduated with a degree in civil engineering some 10 years ago. His name is Tunç Tezel. And what he had to do was, on some occasions, take a road trip to get clear skies. But for most of these, let me see if I can just cut these in half. There we go. But the top half, they were taken around the early evening. So around just after sunrise, just after sunset, as the moon had risen. While these images, so this is early evening, while these images were taken towards the late evening and early morning, so around the time before the moon set and before the sunrise, early morning. So yes, it took incredible dedication. In fact, just to really appreciate what he did, I'd like to play this very short clip. This is off his images put together in a montage. Start off at new moon, and slowly we get each phase coming through. So now we're reaching half moon. Look at that. The gibbous have come, and there, full moon. The gibbous is going. We come back to a half moon, and we slowly return to the crescent until we get very close to the next new moon. Beautiful image. Now the images have actually been done in scale, so you can actually see the variation between the size of the moon as it changes from perigee when it's closest to the Earth and apogee when it is furthest away from the Earth. And to end this off, I'd like to end in a similar way that Tunç Tezel did, which is to invite all of you in the audience to try something out. What I'm going to do, I'm going to mark these down. So let's erase all this. What I want you to do is to try to identify in which of these images was the moon closest to Earth. Which of these images was it at its perigee? So I'm going to mark them here. I've got A, B, C, D, E, F, and G. And then on this side, I'm going to put 1, 2, 3, 4. So use this grid system. For example, if you wanted to call out this moon over here, this would be E2. So use this grid coordinate system and just type it in either in the live chat on Facebook, YouTube, or in the comments down below. In which of these images do you think the moon reached its perigee?
Can you give a hint to the answer? Give a hint, please.
It is, well, because it is perigee, because it is when it is closest, because it is when it's at its perigee, it will be whenever the moon was closest to Earth.
That's the answer. That's the answer. Okay. Now,
Yeah,
see what
that's very good.
check book. I'm in the YouTube and Facebook.
Yes. Have fun.
Thank you.
Okay. I believe.
Yeah, the next one will be me presenting the next APOD. So let me share my screen first. Okay, can you see my screen now? Oh, I know you can see it because Dr. Zhang already. Yeah, this is a very, very beautiful image presenting the APOD image on 23rd of October. So this one you can see is a very, very obvious Milky Way with the whole, the arching and very complete Milky Way galaxy above it's over the Australian pinnacles. So actually this picture is taken by Jing Yi Zhang, and this picture is an old picture taken in the 2017 September. So in the Pinnacle Desert, in the Nambong National Park in the Western Australia. So actually these pinnacles, they are still the topic of the research because it is a geological formation formed like 25,000 years ago, and after the sea recede. And so these are actually the left deposit of the seashells. So over the time, these pinnacles is actually removed by the coastal winds, and then their height can as high as our human height. I think it's about 3.5 meters. So from this picture, we can see Milky Way galaxy. Okay, you can see Milky Way galaxy. Then actually, this is the Alpha Centauri, and then here got the Vega. Here is the Saturn, and here got the Jupiter, and even we can see the meteor here. Then the skies are so awesome with full of stars, and from this picture, aside for the Milky Way, you can actually see these lights, and this light is actually the zodiacal light at this center of the image, and we always call it as the force bound. This is, you can see, is like somehow something you can see is like a cone of the light, and normally appeared when it's during sunrise or sunset. So this is actually time to see the zodiacal light in the southern hemisphere, or in Australia. You can actually see it in the west. So after sunset. So if you are in the northern countries, the hot northern hemisphere, so you just can try to find it in early pre-dawn hours. It's still visible until the early November. So why this zodiacal light? Actually, zodiacal light is from our inner from our inner solar system. So the sun actually reflect the dust grain that orbiting within our solar system. Some they said is the dust from the uh, along Jupiter. And actually, this is quite an interesting subject of study because the dust grain are also the source of the micrometeorite falling on Earth. Yeah. Okay, so okay. So I'll go to my next picture. The next picture is on 21st of October. So this is the also a starry picture and taken in New Zealand by Ian Graffin. He is a photographer and working in Otago Museum. Otago Museum is the one of the largest museum in New Zealand, located in the city center of Dun- Dunedin. Yeah. So this picture, it looks like an artwork to me because you see the colors and the formation. It looks like the Starry Night artwork. So the brightest object in this picture is actually our neighbor galaxy, Andromeda galaxy. So Andromeda galaxy is in New Zealand, you'll never get more than 5 degrees above the horizon. So this is the highest peak already when you can see it in South Island, New Zealand. So the image is actually taken from the Mount John Observatory when the M31, the Andromeda galaxy, just climbed over these Alps uh, in the South Island, Southern Alps. So you can see even the foreground. These are the lake of the Alexandrina. Yeah, very beautiful one. Because this is the image taken from top of the Mount John. So I think it's about this side or something. So the sky and is very clear. Yeah. So Mount John Observatory is also the New Zealand premier astronomical research observatory operated by University of Canterbury. Is actually situated at 1,029 meters at the northern end in the South Island and established in 1965. In the Mount John Observatory, it has actually many telescopes. Yeah. So the Lake Alexandrina also is located uh, near the Lake Tekapo in New Zealand. And okay, so from this image, the M31 is very, very bright. But usually when we see with the unaided eyes, actually we if I see even I use the binoculars, I also hardly can be seen here. But from the top of the Mount John, the sky is so clear and also very dark. You see all the stars here, and photographer Ian he take with the 30-second exposure with the tele zoom lens, and you can see the galaxy is actually have the very large is actually very large, is spinning nearly 6 full moon in this picture. Okay, so I will go to the my last APOD today. This is the 14.
Wow,
Yes,
wow.
very very nice. It looks like the rocket is striking through the moon already. So this picture, yeah. So the the caption for this is the Falcon and the Hunter Moon, taken by Michael Seeley. He is a professional photography and he will take the rockets, and he is from Florida. Yeah. So the Hunter Moon means the full moon in October. So why is that called as the Hunter Moon is because this from history or historical, the hunters are starting to start the hunting activities, uh, and collecting the food and then store it because the cold and the winter moon is coming ahead already. So this is the moon in October is called as Hunter Moon. So from this picture, this one is the Falcon 9 that launched on the 8th of October. Um, so the image was taken by Michael uh, just after the sunset of on October 8th. That the rising skies over the Florida space coast, and actually this is that day, SpaceX they launched two commercial satellite, which is Galaxy 33 and Galaxy 34 satellite to to orbit, and then the first stage is managed to come back and back to Earth. And actually, the nearest launch again by from this for this Falcon 9 was just like 3 days ago, 27th of October. They actually launched the 5G Starlink satellites uh, from California Vandenberg Space Force Base. So uh, Falcon 9 is actually the two-stage rocket and also a world first orbital class reusable rocket. And this reusable vessel is designed to can safely transport people and the payloads into the Earth orbit and beyond. So yeah, this one is the Falcon 9 rocket. Yeah, very nice rocket. Okay. Actually, for this rocket, they actually successful launch for 182 times, and then they have success landing of 142, and they have the total reflight of 120. So SpaceX is actually launched more than 3,500 satellites for Starlink also. Yeah, okay. I back to this picture. You can see this here is there are actually ripples and fringes. Why is it causing so? It's not the moon got what problem on the edge already. It's actually because when the rocket they 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 flies very fast, they launch very fast, and then the rocket passage uh generate the supersonic wave, and then the wave is actually change the atmospheric index of reflection. So um so the light is actually from the moon, we can see is disturbing already. So when we see it from the moon, you can see this uh the ripple. So you can see I ran a clip. You can see when the video the rocket fly through, then you can see the all the ripples and the fringes along the edges of the lunar disk changes so much.
Oh, yo.
Yeah. So it's like all the supersonic wave, and then all the edges starting to uh, disturb. Okay, so here's my APOD. I will pass back to Dr.
Marcus.
Marcus. Okay, I will end my presentation.
Yeah. Good way. Thank you.
Thank you.
Okay. Are you all able to see my screen?
Yes, can see you. Can see the screen.
Okay, so I will start with my first APOD for today. It's the APOD of October 2nd, and it's actually taken not by one person but by multiple different people. And it's Frank Shinzo and a few others from the NRAO and NSF, which is the National Science Foundation, and the National uh, and the, and the National Radio Astronomy Observatory, and the Canadian Galactic Plane Survey, and then there's also NASA. And this image is actually the image composition is actually by Jayen English. So this image was actually taken in not in a conventional way. In fact, this image is actually um, composed of several radio images from the VLA and the DRAO. So the VLA actually stands for the Very Large Array, which is located over here in Socorro, New Mexico. As you can see, here is a picture of what the Very Large Array looks like. And it's also taken by the DRAO, which stands for the Dominion Radio Astrophysics Observatory. It's located up north in Canada. Over here, it's in British Columbia. Actually, it's temporarily closed. And so this is actually a picture of a supernova remnant and a pulsar trail right over here. So this supernova remnant is called CTB1. It was formed 10,000 years ago. And what's interesting about this supernova remnant is that it's actually blasted its newly formed pulsar out into space at 1,000 kilometers per second. And the pulsar is now also spinning at 8.7 times per second. The pulsar is called PSRJ0002 plus 6216, and you can see this is the trail of the pulsar right over here. And if you're curious, here is also a picture of the CTB1 nebula. It's actually located in the Cassiopeia constellation. It's a very beautiful picture. To me, it looks a little bit like a giant jellyfish. You know, if you can see the resemblance, looks a bit like a jellyfish to me. So that's it for this APOD, and on to my next picture. So this is actually a picture of two comets, C/2017 K2 or Pan stars, and 73P Schwarzman-Watchman comet. So this was taken by Jose J. Chambo, and he's actually an amateur astronomer. So this comet, what's interesting about the Schwarzman-Watchman comet is that it has actually been disintegrating since 1995. The comet was discovered in 1930, and the 2017 K2 comet was obviously discovered in 2017, as you can see by its name right over here, and this is actually about 7.8 light minutes away. And now for my final APOD picture. Now this is actually quite interesting. This is an analemma, but instead of it being the sun, it's actually a moon analemma. And if you're wondering what is an analemma, it's actually a curve. It's actually a curve in the shape of number 8, and it's taken. And the way an analemma is taken for the sun is that every day at the same time, you would take a picture of the position of the sun and for over 1 month. And then if you put them all together, you will see it becomes at it becomes it shows up in a figure of an eight, number eight, in the shape of a number eight. But for the moon, however, you have to take the picture 50 minutes and 29 seconds later than the time you took the picture the day before, because the moon only returns to the same relatively the same position 50 minutes on an average of 50 minutes and 29 seconds later than the day before. And this was actually taken over 2 months, from July and August instead of 1 month, and it's taken by the astronomer called Batu Turksoy. And this was actually taken in Turkey, in Kayseri, Turkey, right over here. You can see taken over here. And some of it is actually barely visible because it's it's a slightly darker than the others, such as you can see over here. Wait, let me zoom in. Yeah, as you can see, these are some of the picture moons that are barely these are some of the figures that are barely visible, because these are either during new moons or crescent moons. So yeah, this is a pretty interesting picture, and that is it for my APOD, and I will pass it back.
Before we get on to Dr. Chong, I believe Marcus may have slipped his tongue. When you mentioned the analema, what usually happens with an analema doesn't have to be over a month. Usually that is, it doesn't have to be. It's usually over the period of a year, and you take it from the same position at the same angle at the same time, but over whatever interval you want. So it can be every week, every 2 weeks, just somewhat regular, and usually over a year.
Oh yeah, you're right. I meant to say 1 year. I said 1 month.
Right.
Thank you for the
No,
correction. And now I'll pass it back to Dr. Zhang.
Thank you, Ryan, for your additional information. Okay, so I'll share my screen. A bit slow. October 15. Can see, huh?
Yes, we can.
Okay. October 15, which is actually related to the earlier October 17. I show October 15 first, because that's how before I show you the video, look at what said. Gamma ray burst 2210098, one of the most powerful gamma ray bursts detected in the Milky Way, on planet Earth. Okay, it's a cosmological event. It occurred about in the constellation of the Swan. No, in a very far away, and it is about 2 billion light years away. Okay, and now everyone look at my reaction. Look at my face. Huh? Look at the burst. Again, the burst. Now, why do I shield my hand like that? Because thank you very much that this gamma ray burst occurred 2 billion light years away. Because if it is very near, let's say it exploded in Andromeda galaxy 2.5 million light years away, or even in our Milky Way galaxy, then the energy of the gamma ray actually reaching the Earth, may cause mass extinction. Now remember, scientists have discovered that 65 million years ago, there was a 10-kilometer size asteroid that hit present-day Mexico. Oh la la! And threw up a lot of material into space. And there's a mass extinction event because of that collision of the asteroid on the Earth, and destroyed most of the life form on the Earth, including the dinosaur. But after that event, they have found evidence of even earlier mass extinction event, the famous Permian Triassic mass extinction event, where even more life form, became extinct in a short moment. So they were looking again for possible asteroid and so on. But one of the theses is that maybe a supernova exploded very near to the Earth, and the X-ray and the gamma ray from the supernova saturated the Earth's atmosphere and the Earth's surface and caused a mass extinction. So this one, luckily, is occurred 2 billion light years away. If occurred closer to Earth, it may cause a mass extinction event on Earth. Or if we can predict the event coming, so nowhere we are going to stay for years after this, Bunwei, rain and market, you have to dig underground and stay in the tunnel until no more energy comes out from this object. Now, earlier one is of course October 17, similar one. The ring around the X-ray ring around the gamma ray burst, similar event. Okay, 2 billion light years away. Okay, so it doesn't mean that it's a beautiful event of supernova, but please, for example, many years come out and see Betelgeuse in the sky, 550 light years away. So you tell the Betelgeuse, please explode. But if there's a supernova explosion in Betelgeuse, the visible light is strong, reaching the Earth. But because so far away, the X-ray, gamma ray may not destroy life on the Earth. But if a supernova explodes closer to the Earth, then Earth will be in danger. The whole solar system will be in danger. So please supernova explode so that we can enjoy your view, but not too close to the Earth. All right, that's what we say. The next one is October the 13th. This is an interesting one. This came recently. All right, from our James Webb Space Telescope. I tell you the name first. Dust shells from the Wolf-Rayet 150 star from James Webb, NASA, European Space Agency, ESA, Canadian Space Agency, CSA, James Webb Space Telescope, JWST. MIRI is a kind of mid-infrared instrument in James Webb, and this ERS program 1349 is also from James Webb, and possessed by the famous Miss Judy Smith, and they call her an expert astro images processor. She can process astro images very, very nice. She's not an astronomer, but she can process the image very nice. So let's have a look at this now. Oh, so nice. So what's happening? So it's a binary star system, constellation of Swan, as imaged by James Webb, observing infrared, 2 stars orbiting around each other. So there is a time when the stars are further away. I mean, one of the stars is a more massive star. The smaller star is further away from it. Let's say further away from the object, and sometimes the other star comes closer to the object. So when it comes closer to the object, they interact strongly and eject a shell of dust. Here we see the shell is like a circle, 2 dimensions. Actually, it's a 3-dimensional spherical shell, expanding. So each time the smaller star comes closer to the bigger star, a shell of dust is expelled, and you can tell that in the next what they call encounter, when you orbit out and come back again, closest approach, expel another ring. So you can see how many times are there. So imagine each time it goes around, it's like one period. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in this picture, they're seeing the smaller star orbiting around the biggest star 16 times. Right? So very nice. This is 2 stars orbiting each other and ejecting the dust. So this is the beauty of the universe. Okay, so the next picture would be the 6th of October. The real galaxy. Of course, this is the old picture. All right. So, boys and girls, ladies and gentlemen, welcome to the Astronomical Zoo. The universe. So there are all types of interesting names: the cats, the fishes, the dogs, the birds. All right, and the Eskimo, all kinds of interesting. So this is the whale. Right. And it's in the constellation of Canis Venatici, the running dog. All right, and it's actually taken by an American astrophotographer from New Mexico, Michael Sherrick. Right. So here you see that. Also, now you see that we have this galaxy which is as big as our Milky Way, but this galaxy is seen edge on, not face on, but edge on. Okay, and you see here. Whenever you look at a galaxy, you see those pinkish color and so on. These are the called starburst part of the galaxy, where a lot of stars are being born at a furious rate, right? And then you have the yellow part in the center of the galaxy, and these are the older stars, the yellow stars. And the pinkish one are the younger stars. So you see a lot of stars are being born here, and there's also a sidekick, the dwarf galaxy. Remember, Milky Way has two sidekick, two small galaxy, the large imaginary cloud and the small imaginary cloud. And this also has a sidekick. Okay, the sidekick here is NGC 4627. This one. Although NGC means the new general catalog, there's nothing new about it. The catalog is more than 100 years old, but it's still called NGC, New General Catalog 4627. All right. So this is the Whale Galaxy. All right. And you can see that there are a lot of information we can get from here. In fact, if you look at it in a different part of the electronic spectrum, you can see streams of stars they stretch out. How? By maybe earlier, this Whale Galaxy has neighboring galaxies that are interacting with it, and the other galaxy has strong gravity to pull out parts of the streams of the star and form a stream that's following this. But not so clear here, but we can see in many of the Hubble pictures, two galaxies they are interacting, and when they pass to each other, pass by, so the galaxy which is bigger will pull out the stars from one galaxy. Right? So earlier, one galaxy got a lot of stars, second galaxy got a lot of stars, and they approach each other and go away from each other. So many of the stars in the first galaxy has been robbed, okay, have been pulled to the second galaxy, and the earlier galaxy become the naked galaxy. Only the nucleus of the galaxy is left. Most of the stars have been pulled to the other galaxy. Okay, so this is the case of the Whale Galaxy in Canis Venatici. Okay, so come to the end of my last picture already. So maybe we can see any comment. Rain, can you see any comment?
Not on the YouTube side.
Okay, check on the Facebook.
I have two.
Lodi? Or any one of you got any comment or anything? Marcus?
I see from Facebook the comment from William Chin that we have seen the 73P Swasman Watchman
comment. Yeah.
In 2006 at Pulau Singa Besar before.
Yeah. We were there. Yeah, correct. Yeah, very nice. So,
yeah.
So Boon Wei, Ryan, Marcus, you should have been born 17 years earlier. That's a wonderful place in Malaysia called Pulau Singa Besar. The second island of Langkawi. We went there monthly for about 7 years. Very nice. Can see Milky Way at a glance with your own eyes. Yeah.
Now cannot already, man.
You can go. But all the jetty and all the visitor center is now run down, all collapsed already. That island and the facility was maintained by USM, for the state government of Kedah. And on that island, we from USM and our astrophotographer from other parts of Malaysia go there. The whole island belongs to us. And that island got 5 park guards, 5 security guards protecting the island just for us. They own the whole island.
VIP.
Yeah. So, Rayan, I and this Kenny Low, we are looking at a new place called Tasik Beris in Kedah. We go there often also. So, it may replace Pulau Singa Besar, Langkawi. Tasik Beris in Kedah. A nice location. That area.
Yeah, that is quite nice.
So, our this Boon Wei knows the place even better than us.
No lah, I just went for a few times for.
Okay, but, important question. Can you see the naked eye, Milky Way?
No, actually, the weather in Malaysia is like so many clouds. That's the problem. I went for 2 times. 2 times also cloudy. So sad.
Yeah. So, any comment by any one of you?
Yeah, I see another is, can Rayan reveal the answer for your question just now?
Yes. Please post the picture again, the lunation.
Okay.
Remember, that means the moon is closest to the earth. So which is the one?
I see someone comment, is that A3?
A3? Rayan, please post your picture.
Yeah, I am trying to share. One moment. Hey? Share. You must grant permission in order to screen share.
Never mind. Please share your picture for that day.
I can't share my screen.
Okay, in that case, I will try and see if I can share for you.
It was October the 1st.
October the 1st. Okay, I'll share for you.
Nation Matrix.
Wait, huh?
Okay, so someone said A3. Well, from my knowledge, I believe that A3 would be the one on the left.
Here.
Yes.
First row, second row, third row. Third row, the furthest on the left lah.
Yes.
That looks like it.
Because, as a matter of fact, the full moon does actually land on the perigee, land on the day of the perigee. It is when the moon is at perigee. So, looking at these images, yes, that is most likely the day. The best way to really determine would be to composite all of them, or maybe the middle few, and then see how big they are. But based on prior knowledge and astronomical and astronomy information, yes, that is very likely the answer, A3. So
yeah.
Congrats to whoever pointed it out.
So Rayan, I just want to add on one more information. So basically this lunation sequence by Rayan Interesting is called one lunation. That means as the moon orbits around the earth in 1 month, all right, there are 3 phenomena. Because the location of the sun and the earth and the moon will change. So you see various phases of the moon. Like first new moon, first day, second day, first quarter, full moon, third quarter, old moon. That's called the first type of information. The other one, of course, you see that the size of the moon will increase and decrease. Because the orbit of the moon around the earth is not a pure circle, ellipse. So when it's closer to the earth, perigee, the moon looks bigger. Furthest away looks smaller. And the third factor is called libration. Libration. So as imagine this is okay, I will see your face. Huh? Imagine that this is the moon as seen from the earth. All right. So as it orbits around, I'm the earth, and the moon orbits earth. So as it orbits earth, the moon's surface will rock to the east a bit, rock to the left a bit, rock. So sometimes you see more parts of the east, less of the west, and it go away, it rotate the other way. Sometimes you see more parts of the west, less of the east. So in a sense, question: what is the percentage of the moon's surface we can see from the earth? Answer is not 50%. 4 divided by 7, more than 50%. So that means the moon from the earth, you look at the moon, it will rock like this, rock a bit, and as it orbits the earth. So that's a libration. Okay, so that's it. So now you have the case for lunar phases, one phenomena. Size of the moon can change, another phenomena. The third one, you can see sometimes the eastern limb more better, western limb less exposed. After that, half lunar orbit later, you see the western limb better, eastern limb less. Libration. So this is the 3 effects, and it's called the one lunation. All right, interesting. Okay. So any more comment by anyone? Okay. Yeah? So Michael, are you there? Yeah. So you want to end now? Okay. Thank you, Michael. Huh? Thank you. Stop sharing the screen. I'll stop presenting. Okay. So don't go away, Moonway, Rain.
Okay.
Michael. Okay. So thank you everyone for observing today's October 2022 what we call APOD session by the Astronomical Society of Penang. Okay, Astronomical Society of Penang is located in Penang, a small island in the northwestern corner of the peninsula of Malaysia. Right. So the north of Penang is Thailand. The west is Indonesia, Sumatra. Right. On the island of Penang, Astronomical Society of Penang. Again, thank you for following our APOD session. Right. So we again present also more interesting picture for next month, November. Right. Thanks again to everyone.
See you next month.
Yeah. See you next month.
Bye bye.